I am Dr. Praveen Chaurasia in the Department of Electronics and Communication Engineering from IMS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. In this lecture, in this fourth lecture, I will talk about introductory part of digital image processing, in which I am covering fundamental steps of digital image processing and its physical aspect, which is one of the step of, that is, image acquisition. So, in previous lecture we have talked about complete fundamental steps of digital image processing. So, in which one of the important aspect, one of the important steps, that is called image acquisition, we have already completed, and its physical aspect we will talk about in this lecture. Before that, we will also talk about remaining steps of digital image processing. So, let us have a look. We have completed image acquisition in previous lecture, and after that we are going for image enhancement, then image restoration, then image segmentation we will talk about, and image analysis. After that we can observe, and the last one, that is called image compression. So, one by one we will talk about all of these 5 parameters of digital processing, which is only done in image, digital image, right. Now, if we talk about image enhancement, so related to image enhancement word, you already identify these two images. This is the first image and this is the second image. So, that image if you observe, then you can say there is the portion at which you cannot identify clearly of that particular information. In this image, that is more clear vision of this particular image. So, one can say that that image is actually enhanced with respect to one of the filter, or we can say so many techniques we can offer for enhancing these kind of image into these enhanced image. Okay. So, that is the actually image enhancement process, by which you can identify the suitable picture of your input image by using the deblurring, or you can say sharpening of image, highlighting the edges, or you can say that portion you are highlighting more clearly. So, you can say your image is actually enhanced, or you can say improvement in the image contrast, you are actually enhancing the image contrast. So, you can also say your image is get enhanced, brightening or image removing noise. So many noise you can remove, so that you can say your image is actually enhanced. Another portion if we talk about, that is called image restoration. So, there is very, you can say very minute difference between image restoration and image enhancement. Here you can observe these two pictures. This is the first picture and this is the second picture. That picture is actually very much old, and you can say, you can observe here that portion is completely breaked, okay, broken here. So, how you can identify that broken image, what is the image is actually present earlier, that thing you have to identify. After identify, if you put that thing here only, then you can say your image is completely restored. So, see, this is your original image, and after the restoration process you may observe that portion is completely filled by neighbor pixels. You can say that pixel is actually filled here, okay, or might be that pixel you may fill here. So, by using this process you can say your image is completely restored and it will look like this one. So, restoration is the important kind of, is one kind of image enhancement, by which broken portion, or you can say that portion is which actually is not present there, that thing you can also identify using the restoration process. So, by removing of blur caused by a linear motion, removal of optical distortion or removing periodic interference, these kind of process you may observe related to image restoration. So, that thing you may observe related to image enhancement as well as image restoration. Then if we talk about the another fundamental step, that is the image segmentation of digital image processing, then you can say your actual image can be sectorized, or you can say segmentically segment using the segments you can summarize your image in this manner. If you think this image, this is your input image, this is the another kind of image, this is the another kind of image, and that one is also another kind of image. If you summarize all the image, then you can say A is equal B plus C plus D C. So, we can say B has a sum of the parts, sum of the segment of A, C can also have sum of the part of segment A, and D, that is this one, is also have sum of the part of image A. So, if we talk about all these three images is actually providing the complete image. So, if some of the portion, some of the important information is present inside the segment of original image, then you can identify that information using the image segmentation. Okay. So, that portion is actually important in this respect, in this regard. So, it involves subdividing an image into constituent parts or isolating certain aspect of an image, finding lines, circles, particular shapes. In an aerial photograph, that is important part is present using image segmentation. So, that is all about the image segmentation portion of digital image processing. Now, if we talk about another fundamental steps of digital image processing, that is called image analysis, and in another word you can also observe that is called wavelets. So, see, using the wavelets transform, that transform is also is there. So, we will also talk about the wavelet transform. So, image analysis is one of the very important analysis related to digital image. So, see, if we have a scale 1 of one original image that is look like this one, then using the another kind of scale 1, scale 2 to 5, then your image analysis at the end you may observe in this manner. So, you can say that complete image is thoroughly analyzed, and using the wavelet transform you can also get the information of each and every pixels. What is the density, what is the intensity or density of this pixel, you can easily identify using the image analysis or wavelet analysis. Wavelets are used to represent the images at various degrees. Okay. So, by using the wavelet transform you can identify the degree of each and every scale. It also used for compression. So, if we talk about the complete information is present in scale 1, and if we talk about the information which is present in scale 5, that is very less. So, you can say scale 1 is your original image, it will require more size as compared to scale 5. So, scale 5 is actually having very less information, or you can say many pixels are missing which is not needed actually. So, it is also useful for image compression. Okay. Now, so the steps of digital image processing we have completed here, and after that how we can image acquisition using the fundamental steps of digital image processing, and the what is the physical aspect is present related to this capture of image, then that thing we are going to talk about here. Now, see, If we talk about the structure of eye, some part we have also completed in previous lecture of this human eye. So, see the spherical in shape with average diameter approximate 20 millimeter is the size of human eye, and there are three membranes encloses the eye cornea and sclera as outer cover, choroid retina that is the outer portion. Iris or pupil varies in diameter approximately 2 to 8 millimeter, and the last but not the least, that is the lens which is present in a human eye. So, see this is the complete diagram of human eye. So, here we already talked about these three processes, that is the image formation, transduction and processing. So, related to image formation, these all parts of human eye is actually are the responsible to form the image in a human mind. So, first that is the cornea, sclera, pupil, iris, lenses, retina and fovea are completely responsible to form a image of your mind. After the second portion, second process, that is called transduction. So, these three came into the picture, that is the retina, rods and cones. After the transduction process, you can identify that image. So, these two terms is actually useful to process the image. So, see these are the optic nerves, this is the blind stop, fovea, retina, choroid, sclera and cornea, and this is the lens. So, these are the common part of image, that is also the iris, that is also important to form a image because it is needed for image formation. So, after that these three process you can form a image in a human brain, and after the brain, after the optic nerve signal, you can identify that image. So, see fovea and retina are playing very important role to form an image. That is why we are talking about the physical aspect of human eye. So, retina has photosensitive receptors at the back of eye, fovea is a small dense region of receptors, cones are there only, there is no any rods are present, visual acuity it will provide us. Outside the fovea, fewer receptors overall, larger portion of rods are actually present there, and these are the important terms you can identify inside the eye. These are the optic nerve which is actually responsible for processing purpose, because optic nerve is actually the processing part of an image, that is actually the physical aspect of human eye. So, optic nerve and brain, how they are forming each other, that thing we are talking about in this slide. So, these are the optic nerve, right side, right portion, ganglion, this portion is called the ganglion, each and every optic nerve is present that ganglion. Bipolar cell, these bipolar cell is actually useful to form a bridge between cones and ganglion. Rods, these kind of portion or parts we can say, these are the rods which is actually responsible for transduction process. Okay. So, this is the internal structure of human eye. So, here you can also highlight some of the point, that is the transform of light to neural impulses is actually doing in this processing. Receptors signal bipolar cells are important, bipolar cells signal ganglion cells, these kind of cells. Axons and in the ganglion cells form optic nerve. So, from right to left you are just explaining this entire thing. Then if we talk about the difference between cones and rods. So, see the simple difference for the cones and rods are, if we talk about cones, then in each eye numbers between 6 to 7 million. Cones are present 6 to 7 millions in a human eye. But if we talk about rods, 75 to 150 millions rods are present in human eye. Okay. So, rods are actually higher than cones in human eye. Second difference, if we talk about, then it consists photopigments. Okay. So, that is the similarity between rods and cones. It also consists photopigment. Third one, if we talk about third point, that it responds to high energy, but rods, because it is higher number is present in your human eye, then it will also respond to the lowest energy. Okay. For this high energy is required, but if we have a low energy reflection, then rods is also the part of your action. Okay. Now, if we talk about the another point, enhanced perception, but if we talk about rods, it enhance sensitivity. Another point, if we talk about, then concentrated in a fovea exists sparsely in retina. Similarly, concentrated in retina, but outside of fovea. Okay. It is outside of fovea, but sparsely in retina. It is related to retina. It is very near to retina, but it is outside of fovea. It has three types, sensitive to different wavelength. Each and every wavelength response to the cones is very much different manner. If we talk about sensitivity using the rods, then only one type it has, sensitive to gray scale changes. If gray scale is changed, then it is actually responding the changes, otherwise there is no change in your sensitivity. Now, by using this diagram, we are actually identifying the blind spot. Now, see on the y axis we are talking about number of rods or cones per meter square, per millimeter square, and the x axis we are talking about degrees from visual axis, that is from center of fovea. So, it is actually representing the distribution of light receptor over retina. Now, see the hard line is actually representing the cones and the dotted line is representing the rods. So, see if number of rods or cones are enhances from 45,000 to 90,000 up to 1,35,000 and 1,80,000, and the degrees from visual axis is from the minus 80 degree, minus 60 degree, minus 40 degree, minus 20 degree, 0 degree, plus 20, plus 40 degree, plus 60 degree and plus 80 degree. Then these kind of degree if you are observing, then see the blind spot is actually near about the minus 20 degree, at where your cone is also not responding and your rods is also not responding on that portion. So, that is the blind spot you may observe in your eye. Okay. So, that thing you can see, if cones and rods are not responding at that particular portion, then you can say that spot is actually related to blind spot in your eye. Otherwise, at where your cones are responding, cones are not that much useful for the response, then you can say the rods are useful for the response. So, see if it is lower, then it is higher. Similarly, if it is lower, then it is higher. So, and here the opposite nature is present, then you can observe the cones are in much more action, then your rods action is much more lesser. Okay. So, at those portion you may observe, so somewhere cones are acting and somewhere rods are acting, but at that particular portion if both are not acting, then we can say that is called the blind spot. Okay. So, that blind spot we have to observe here. So, after that you can identify these blind spot using this phenomena, or we can say using this diagram. So, at where in x axis degrees from visual axis, which is actually giving from the center of phobia, and what is the phobia, center of phobia, where it is present. So, this portion is actually the center of phobia. So, your blind spot is actually present in this direction. In center of phobia, if we moving clockwise, then we can say you are moving the negative, you are moving the positive direction of angle, and if you are moving the anti-clockwise, then it is the negative angle. So, that portion is actually you are observing, and after that portion you can identify this graph, and using this graph you can also identify the blind spot. Okay. So, both are not working, both cones and rods are not acting actually, then we can say this is the blind spot. Okay. By which no one can understand which kind of image is actually present in front of your eye. Okay. And these are the references which is actually I am going to use for this particular topic, which is actually the physical aspect of digital image processing and fundamental steps of digital image processing. Okay. So, here the third one is very much important. So, see, this publication is actually giving the idea of wavelet transform and image analysis, which is the very much important fundamental steps of digital image processing. So, wavelet and its application is actually giving much more identification of image. So, that portion is actually required to identify image analysis and their information. Okay. So, that is all about the third lecture, and for the next lecture we will talk about later. Thank you.